All right, no issues. Okay, so I'll just turn off the cam, otherwise the quality will reduce. My name is Professor Pereira from RIT Engineering College, and today we are basically going to learn how to find voltage across any 2 points in a given circuit. Now, if we talk about finding out voltage across any 2 points in a given circuit, it is basically taking any one point and finding out the voltage with respect to the other point. So now if I'm saying any 2 points, for example, say voltage across C and F. So across C and F. So I want to find out the voltage across these 2 points, C and F. Now practically, if we see, or practically if we want to find out the voltage, what do we do is, if we have a circuit like this, and you want to find out the voltage this resistor and this voltage source of 5 volts, the 2 points will be here. So practically we will take a voltmeter and connect one terminal of the voltmeter at C and the other terminal of the voltmeter at F. So in a practical circuit, if we want to find out the voltage across C and F, what we do is we will take a voltmeter or a multimeter. If it's a multimeter, we'll put it on voltmeter mode and we will connect one of the terminal to C and the other terminal to F. Now a voltmeter has two terminals, as we know. It has the positive and it has the negative. So the red wire or the red terminal will be connected to C and the black wire or the black terminal of the voltmeter will be connected to F. Well, so if we want to find practically the voltage across these 2 points, one terminal of the multimeter will be connected across C and the other terminal will be connected across F. So if you want to find the voltage VCF, the positive terminal, the first positive terminal will be connected to the first point, that is C. So your positive terminal will be connected to C and your negative terminal of the voltmeter or the multimeter will be connected to F. So once we connect both these terminals, we will find out the reading and gauge the value of the voltage across. So this is how it is done practically. So basically, C is connected to the positive wire and F is connected to the negative terminal. So we have positive and we have negative. Now this is basically practical, but now if we want to find out the voltage theoretically, we basically can find it out using the same KVL concept that was taught before. So if we want to find out the voltage across VCF according to KVL, which states that number of voltage sources in that loop equals to the number of voltage drop in that same loop. So we can take any loop. We can take across this loop, we can take across this loop, we can take across this loop, or we can take the voltage across this loop. No matter which loop you take, you will get the same value. Now to make it simpler, we have points A, B, C, D, E, F, G and H. So if I am considering this loop, which is the most fastest and the easiest loop, it is the voltage across C and F. So I am moving from positive and going to negative. However, the converse is also possible. You can move from negative and then go to positive. But it is across these 2 points, so via C and F. Now I can even go via this loop as well. So this will be from C to D, from D to E and E to F. In the same way, I can even go from C to B, B to G and G to F. Another way could be from C to B, B to A to H, H to G and G to F. So no matter which way you take, whether it is the long way or it is the short way, your answer will be the same, maintaining the equilibrium in the circuit. So you can take either the shortest part or you can take the longest part, you will get the same answer. So better is to take the shortest part to solve it quickly. So this is how you can find out the voltage across any 2 points in a given circuit. In the same way, if you want to find out the voltage AG, so I have 2 terminals here, A and G. Now the shortest way would be this, from A to H and H to G. We already found out the value of AG, it is 20 volts. But if the value of AG is 20 volts here, I should even get the voltage across points A to B, B to G also as 20. In the same way, from points A to B, B to C, C to F, F to G also as 20. Would be A to B, B to C, C to D, D to E, E to F and F to G. This also will be 20 volts. Now what we have to remember here is, it starts at A and you have to end at G. So whichever it is, it has to end up at G. So this is basically how you can find out your voltage. So I have purposely taken these 2 points, that is points A and G, so that, because I already know that the voltage across A and G is 20 volts. So no matter which loop you take, your end result will go as 20 volts. So this is how it is done. Always remember one thing, the first terminal is taken as positive and the second terminal is taken as negative. In the same way, we can find out the voltage for AG as well. Since A is the first terminal, it is positive, and G is the second terminal, it is negative. Because whenever you consider VAG, the voltage across AG, your positive terminal will be connected to the first terminal of the multimeter, which is here. So this will be positive, and your G point, your second terminal, will be negative. Your multimeter has 2 terminals, as I said, it has a positive and it has a negative. So the positive will be first connected to A and the negative will be connected to G, and you find out the voltage across this points. So you can travel to whichever way which we have already discussed. So this rule will never change. Now, another thing, to find out the voltage across V. Now we have a D terminal here and we have a E terminal here. So what is the voltage across VD? The shortest part would be via which is 30 volts. So we already know now VD is 30 volts. How the voltmeter will be connected? The first terminal or the positive terminal of the voltmeter will be connected to D, and the negative terminal will be connected to E. So you have your positive terminal D and your negative connected to E. So this also will have a positive here and a negative here. Now let us proceed further. So always remember to highlight the first terminal as positive, second terminal as negative. Positive, negative, positive, negative, positive, negative. Alright. Now once this is done, say you want to find out the voltage across VCF. Our first unknown. So across VCF. My first terminal of my multimeter, which is my positive terminal, will be connected across C, and my negative terminal will be connected across F, which is already done. Now, the shortest path wherein I can find out the value of VCF would be from C to F. I can even find out from C to D, D to E, and E to F, which will also give me the same answer. Or even this, or even this. So we will first find out the voltage across VCF. Now, before we go to find out the voltage across VCF, VCF have two components. First is your voltage drop across the 2 ohms resistor and your voltage source. So VCF is equals to the voltage drop across the 2 ohms resistor and the 5 volts voltage source. So we have V3 which is equals to 5 volts and we have 2 ohms resistor. But if we want to find out the voltage drop across this resistor, we will have to know the current that is flowing in this resistor. Now according to Ohm's law, we have V equals to I into R. R value is already given, it is 2 ohms. We don't know the voltage and the current is also unknown. So basically we need to find out the current in this 2 ohms resistor. So how can we find out the current in this 2 ohms resistor? As we already learned through Maxwell's loop current method, wherein we have two ways, the simultaneous equation mode and the matrix mode. So we can use Maxwell's loop current method and find out the loop currents and thereby finding out the value of current flowing in the 2 ohms resistor. So according to Maxwell's loop current method, the first step that we require is to basically highlight all in the circuit. So I'll call this as loop 1, which consists of current I1. I'll call this as loop 2, and I'll call this as loop 3. This is according to Maxwell's loop current method, which we have done in the previous video. If you have any related with it, you can always go back to the previous video and check how Maxwell's loop current method is done. I have even explained a direct shortcut method wherein you can get the equation in just one step. So we will basically use that shortcut method. If you want details, you can always go back and check how you get that one-step equation. So, if this is loop 1, the current flowing in this loop will be I1. If this is loop 2, the current flowing in this loop is I2. And if this is loop 3, the current flowing in this loop is I3. So if we are going to use the shortcut technique that I taught you earlier in Maxwell's loop current method, there are 3 things we have to do. First thing is circle the loop or circle the so this is one loop. So I'll call this as loop 1. This is a second loop. So I'll call this as loop 2. And this is the third loop. So I'll call this as loop 3. So we circle the independent loops. After this, we represent loop 1 current as I1. We represent loop 2 current as I2. We represent loop 3 current as I3. After this step, we have to assume all the directions in clockwise. Now, if you want to use the shortcut method, we have to compulsorily assume all the directions in clockwise way. So, I have I1, which is assumed in clockwise. I have I2, also assumed in clockwise. And I have I3, which is also assumed in clockwise. How to use this method as I told, no matter, even if you know that I3 is not flowing clockwise because of the higher magnitude of V5, which is 30 volts, although you feel and you can easily come to know that it is going to be anti-clockwise, still you have to assume it in clockwise. The shortcut method won't work. So once you have assumed the directions, then we basically have to put the polarities of all the voltage sources. Now, putting the polarities is also a very crucial step here. Voltage sources polarities will never change, so we can directly input the polarities of the voltage sources. Now, once your loops are drawn, your currents are named, and your directions are assumed clockwise, and the polarities of your voltage sources are designated. After that, we can start a direct method. So, using KVL in loop 1. Now, as per the shortcut method, if we have loop 1, this is my loop 1 or my mesh 1. KVL states that the number of voltage sources in the loop is equal to the number of voltage drops in that same loop. So how many voltage sources I have? I have V1, I have V2. Now V1, your current that is flowing from V1 will move from positive to negative. see the loop and see my finger. It's moving from positive to negative. So what direction is this? Clockwise. Clockwise is matching with this, so this is positive. So we have plus 20. Now what about the voltage in V2? How the current is moving from the voltage in V2? From positive to negative. So it is moving in the anti-clockwise direction. Is this direction matching with my I1? No. I1 is moving in clockwise, this is moving in anti-clockwise. So the current due to V2 is moving from positive to negative, so which is anti-clockwise. So it will be plus 20 minus, and this is 5 volts, the voltage across V2 is 5 volts. Now, if we want to find out okay, 3 minutes before 5 volts have to be added in, and V2 value is equals to 5 volts. So now, if we want to find out the equation in loop 1, so KVL, using KVL in loop 1. So KVL states that number of voltage sources in a loop is equal to the number of voltage drops in that same loop. So we will first check the voltage sources in this loop. So this is loop 1, which is A, B, G, H. So this is one loop, loop 1. So how many voltage sources are there? We'll keep voltage sources on one side and drops on the other side. So we are having V1 and we are having V2. So we are having two voltage sources. Now, the current developed due to V1 will always move from positive to negative, because current moves from positive to negative. So we'll trace that due to V1. This is V1, we have positive terminals here. So current will start from positive and go to negative in this particular loop. So see how my finger is moving? It's moving in which direction? Clockwise direction. So this clockwise direction is matching with the direction of I1. So if it is matching with the direction of I1, which is also clockwise, the value will be positive. So it will be plus 20. Now, selecting the other voltage. Again, current moves from positive to negative. So the current due to V2 will also move from positive to negative. But in which direction it is moving right now? My finger is tracing which direction? It's tracing the anti-clockwise direction. So it is moving in anti-clockwise direction, which is in opposition to the direction of I1. I1 is in clockwise, this is in anti-clockwise. So it will be 20 minus 5 volts. So 20 minus 5 volts will give us 50. So it is a very easy concept. And always remember, trace the circuit from positive to negative or negative to positive. And that way you will come to know whether the direction of I1 matches with the direction of your voltage sources. So 20 minus 5 gives us 50. Now we have to basically find out the voltage drops in this circuit. Now, how many resistors are there? We have a 5 ohms resistor in this loop 1 and we have the 3 ohm resistor in this loop 1. You have to only take with regard to loop 1. So we have two resistors, 5 and 3. But I1 is flowing in 5 ohms. As we see, I1 is flowing in 5 ohms. And a part of I1 is even flowing in 3 ohms. So basically I1 is flowing in 5 and 3. So we add both the resistors. 5 plus 3 will give us 8 I1. But now as we see, part of I1 is flowing in 3 ohms. But this is a junction. So this 3 ohms resistor here is not only interacting with the I1 current, it is even interacting with the I2 current. So I1 is flowing from top to bottom and I2 is flowing from bottom to top. So you have I1 coming here and you have I2 coming from the other direction. Now in the shortcut method, any current not pertaining to that loop, not pertaining to that loop should be taken in a negative sign. So if I'm talking about loop 1, my I1 will always be positive. If I'm talking about loop 2, with regard to loop 2, my I2 will always be positive. If I'm taking the loop 3 equation, in the same way, my I3 will always be positive, but others will be negative. So any other current which is not pertaining to that loop will be taken as a minus sign. So in the shortcut method, you can just directly write a minus sign here. Now I2 is flowing in which resistor? With respect to loop 1, it's only flowing to the 3 ohms resistor. So it is 3 I2. So this is the drop across your resistors. Drop is nothing but your voltage drop, and Ohm's law states that V equals to I into R. So we have a R and we have a I. So I into R will give us, again, I into R gives us, so we found out the drops. So now this is my equation 1. So I just got it in one step. So I'll just write the loop 2 equation quickly. And the loop 3, which is minus 35 equals to minus 2 I2 plus 10 I3, which is my equation. The systematic breakup of this is basically already explained to you in the previous episode. But just going briefly, now if I am applying the KVL in loop 2, how many voltage sources are there? 5 volts, 5 volts and 5 volts. Again, current moves from positive to negative if I am taking this voltage source of V2. What is the direction? Clockwise. Matching with this, so it is positive. What about V4? It flows from positive to negative. Finger is still moving in the clockwise direction. Again, matches this I2. What about this voltage source? 5 volts. Current moves from positive to negative. Again, my finger is moving in the clockwise direction. So it is again positive. So it is plus 5, plus 5, plus 5, which gives us 50. Equals to number of voltage drops in this loop 2. How many resistors we have? We have 3 ohms, we have 4 ohms, and we have 2 ohms. Now I2 is basically flowing in the 3 ohms, it is flowing in the 4 ohms, and it is even flowing in the 2 ohms. So I add all these resistors. So 3 plus 4 plus 2 gives us basically 9 I2. As it is pertaining, I am talking with regard to loop 2, and loop 2 is pertaining to I2. So I2 will always be positive. The others will be negative. So I got my 9 I2. Now, in the 3 ohm resistor, this is the junction. So the 3 ohm resistor is basically interacting not only with I2, but it is even reacting with I1. So the current in the 3 ohm resistor is a combination of I1 and I2. I1 will be from top to down and I2 will be from down to top. So anything other than loop 2, any other current other than loop 2 will be taken as minus. So we have minus 3 I1. And in the same way, we have minus 2 I3. So whatever other currents are there will be taken as minus. Now coming to loop 3. Now in loop 3 how many voltage sources are there? We have two voltage sources, one of 5 volts and one of 30 volts. As we all know, current moves from positive to negative. So consider this, positive to negative. What is the direction? Clockwise or anti-clockwise? Definitely it is moving in anti-clockwise, which is in opposition. So this is minus. What about this? This is also moving from positive to negative, which is anti-clockwise. So again it is minus 30. So minus 5 minus 30 will give us minus 35. So minus 35 equals to, now we have to find the drops. Now we all know I3 is flowing in the 8 ohms and it is even flowing in the 2 ohms. So I add both this 8, 9, 10. So 10 I3. Now any other current from the other loops which is interacting with that resistor pertaining to the loop that we want will be taken as minus. So 2 ohms is interacting with the I2 current, so it is taken as minus 2I2, which is written here. So in this way, we can avoid all the tedious steps and just write it in equation 1, 2 and 3 effectively, thereby saving time. So you can get your equations in just one step. Now once you get these equations, you can use your calculator, which is either X991 ES or ES plus, and find out the values of I1, I2 and I3 using simultaneous equation mode in your LC. So once you input these values in your calculator, you will get the value of I1 as 2.56 amps. I2 you will get as 1.82 amps, and I3 you will get as minus 3.14 amps. Now if you see here, you got all your currents. If your current is in positive, if your current comes in positive, basically whatever direction you have assumed is correct. So I got plus 2.56 here. So whatever direction I assume for I1 is correct. Now keeping the value, putting the value in the library. So I1 equals to 2.56 amps. What about I2? I2 is also equals to 1.82 amps. And the direction is the same that we assumed. But the value of I3 is equals to minus 3.14 amps. Now, if we get a negative value, that means whatever direction that we have assumed for I3 is wrong. So if I have assumed the direction for I3 in clockwise, then actually the direction is not clockwise, it is in anti-clockwise. So I change the direction to anti-clockwise. Once I change the direction to anti-clockwise, this minus 3.14 will become plus. So in your next step, you have to again write down the currents. I1 equals to 2.56, I2 equals to 1.82, and I3 equals to 3.14, since we have changed the direction in the diagram. So you have to draw this diagram again and change the direction of I3. So this will be your updated diagram with all your loop currents. I will input the current of I3, which is equals to 3.14 amps. So now I got I1, I got I2, and I got I3. Now, moving on further to find out what is the value of VCF. But before we go to this, we have to assign the polarities of all the resistors. Now, when your current basically moves from positive to negative, okay, the first terminal that it touches becomes positive, and the second terminal it touches becomes negative, as that of a resistor. It means, say in I1 loop. In I1 loop, the direction of current I1 will be as per the loop. So if this is I1 and this is my direction, okay, the first terminal that my current touches of any resistor becomes positive, and the second terminal becomes negative. So this is how the polarity is assigned. Then in I2, the first terminal it touches like green chalk. The first terminal it touches becomes positive, and the second terminal it touches becomes negative. In the same way, for loop 3. In the same way, for now here the direction is in anti-clockwise. So I will get an anti-clockwise direction in this loop. So this will be my I3. So the first terminal it touches becomes positive. The second terminal it touches becomes negative. Now this is with regard to loop 1. But in these loops we have two junctions, and the two junctions are caused by the 3 ohm resistor and the 2 ohm resistor. Now, currents flowing in this resistor. That current is I1 and the other is I2. So I1 and I2 is flowing in this 3 ohms resistor. What about the 2 ohms? You have I2 and you have I3. Now, how we will come to know the directions in this resistor? It is pretty simple. This is your I1 direction. It is flowing from top to down. And what about I2? I2 is flowing from down to top. So it will be a combination of I1 minus I2. Because I1 is flowing from top to down, and I2 is flowing from down to top. So it will be I1 minus I2. But what will be the effective direction? This can be found out on which is greater. I1 is greater, I2 is greater, definitely I1 is greater. So the effective direction will be taken from top to down. So So you just have to see which of the currents is greater, that will give you your direction. Since I1 is greater, it will be from top to down. So we have 2.56 minus 1.82, which will give us, so the current here will be 0.74. top to now. So we have 2.56 minus 1.82, which will give us, so the current here will be 0.74 amps. So the current gives us 0.74 amps. In the same way, you can even find out a current flowing in the 2 ohm resistor. Now in the 2 ohm resistor you have I2 also flowing in it, and you have even I3 flowing in it. Again, the direction is determined by the highest value of current. Which is the highest value of current? I2 or I3? Definitely will be because 3.14 is greater than 1.82. So you can directly put your direction here. So it will flow from top to down. Now, what will be the value? You have I2 flowing in this direction and you have even I3 flowing in this direction. So you have I2 and I3. So the effective current flowing in the 2 ohm resistor will be I2 plus I3. So here it is additive because both the currents are flowing into the 2 ohms resistor. So 1.82 plus 3.14 will give us 4.96 amps. Now again, we will put the polarities. This is the effective direction. The first terminal the current touches becomes positive, and the second terminal it touches becomes negative. Now again, here the first terminal the current touches becomes positive, and the second terminal it touches becomes negative. Since I got the direction, so positive, negative. Now once you found the current through each and every resistor and assign its corresponding polarities, we can move on to the next step, that is to find out the voltage across any 2 points. So say we want to find out the voltage across VCF. So across point C and F. Now as I told you can either start from C and go to F directly. So this is one loop. You can even take these points C to D, D to E, and E to F. So you can either go in this loop as well. You can even take this loop as well. Or you can take this loop as well. So let's take the shortest route, which is via points C and F. So via points C to F, which is the most shortest route. So you're going to avoid all your tedious calculations by shortening your steps. So across points C to F. Now always remember, the first terminal of your multimeter will be connected to your positive terminal, and the second terminal of your multimeter will be connected to your negative terminal. So your red terminal will be connected here, and your black terminal will be connected here. So C will always be positive by default, and F will always be negative by default. So the potential C is positive and F is negative. Now we are from points C to F. So you can start from C and go to F, or you can start from F and go to C. So we will consider the first case. Okay. We will consider from starting at C and then going to F. So this will be my start and stop. So starting from C, the first terminal it comes in contact is the first terminal of the resistor. What is the first terminal of the resistor? Positive. So my sign polarity is positive. Now I have to find out the voltage across this. Voltage across this will be what? According to Ohm's law, we have V equals to I into R. So I is what? 4.96. What is R? 2. So 4.96 into 2. 4.96 into 2 ohms. Then again the first of the voltage source. Now the first terminal of the voltage source is the negative. Again multiply positive with the negative. So with reference to C we have a positive. So positive into negative will give us negative. Negative what? Negative 5. Now voltage source is 5. So we already have the voltage. We don't need to use any other Ohm's law or any other equation, because voltage is direct voltage value which is 5. So we have minus 5. So substituting this, we get the value as 4.92 volts. So now we basically move from C to F. In the same way, we can even start from F and go to C. The value will come the same. So let's check this. Moving from F to C. Now, F is what? Negative. Okay, F is negative. Now, this will be your start point and this will be your stop point or your end point. So, if this is your start point and if F is negative, so we are moving from F. So, the first terminal it comes in contact is the 5 volts voltage source. What is the polarity? Positive. Again, multiply both. Negative into positive, negative. That's why you got minus 5. Then again, moving on top. The first terminal that comes in contact is negative. Again, negative into negative, positive. So we will get the same value. So either you can start from C and go to F, or you can start from F and go to C. The only point of consideration which you have to take into account is the polarity of the first terminal. Always remember, since the first terminal of your multimeter is positive, your first terminal will be connected across C, which is your positive terminal, and your second terminal will be negative. So you have to remember this, that your first terminal is your positive and your second is your negative. No matter which side you start, you may start from C and end up at F, or you can start at F and end up to C. But remember the polarities. The polarity will not change. So the first point will be positive, the second point will be negative. So now we found out the voltage across VCF, which is equal to 4.92 volts. But now this is across C and F. So wire points directly C and F. Now we can even go wire points C to D, D to E, and E to F. You can even go wire points C to B, B to G, and G to F. So you can either go in this loop, or you can go in this loop, or you can go directly. Your answer should come same. So we will just prove whether we will get the same value or not, to check the consistency of this theory. So, although you got the value of VCF, which is 4.92, we will go for the second method, or we go for the second loop. Now, when we go for the second loop, we should get also the same value. So, for the first, we went via point C to F, wherein we got the value. Now we will go via points C to D. Go via points C to D, D to E, and E to F. So even if we go via these points, we should get the same voltage that is 4.92. Here also, if we go via these points, we should get the same voltage. Even if we go via these points, we should get the same voltage. So we will just check the consistency of this technique. Now, across C and F, this will always remain same. The positive terminal of the multimeter will be connected across C, and the negative terminal of the multimeter will be connected across F. Now, going via point C to D, D to E, and E to F. So, if I am moving from C to F, as I told you, you can even move from F to C. So now I am basically moving from C to F, that is, I am starting at C and ending at F via point C, D, E, F. So starting at C, the first terminal I meet is the 8 ohms resistor, and it is the minus terminal. Again, positive into negative, negative. So I have to multiply. Clear? So positive into negative, negative. Find out the voltage drop. What is the current flowing in the 8 ohm resistor? It is I3, which is 3.14 into 8. Now, again, moving from C to D and now from D to E. Now, when it is moving from D to E, the first terminal it touches is a positive terminal of your voltage source. So, positive into positive, positive. So, it is 30 volts. So, I get a value of 4.88 volts, which is nearly the same as 4.92. So again, the consistency of this is proved. If we shift, if we take a decimal shift, it will become 4.9, which is nearly equals to 4. continue this next class. Okay, I'll just take your roll numbers. Okay, Tosif, present.
Yes, sir.
Ajay
Present.
is absent.
No, sir. Present.
Yeah. Tosif present. Okay. Ajay absent. Jadav 03. Jadav absent, no?
Absent.
Arsha present. Pradeep present. 06.
Present.
06. Absent. 08. Present. Rohidas. Shubham 09. Present.
Present, sir.
C. Present. Yatin is come. Yatin absent.
No, sir.
Okay.
No, sir.
All right. Okay, guys. Take care. Bye.
Okay.
Bye. Bye.